Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Farhan bin Muhammad Faiz. So I'm gonna present to you about the energy storage technologies. So let's start with our introduction. With the introduction, I separate it into three parts, which is global power release on all fossil fuels, limited supply, and high pollutions. Most of the world's electricity comes from coal, natural gas, and oil. These resources are finite and could run out within a century. They also release greenhouse gases and harmful pollutants that damage the environment and public health. For the second one is renewables. Solid wind are growing fast but are intermittent. Solar and wind energy have expanded rapidly over the last decades. But they only produce power when the sun is shining and the wind is blowing. This makes it hard to rely on the sun as the main energy source without extra support. And for the last part is energy storage system. Store excess electricity for later use. ESS can surplus renewable energy during low demand periods and release it when peak demand. This ensures the steady power supply even when renewable generation is low. Okay, so let's move on to the next part, which is innovation idea plan. I also divide it into three parts, which is concept overview, rationale, and system configuration. Let's start with concept overview. A hybrid system uses second life EV battery for a short-term responses and green hydrogen for long-term storage to overcome lithium-ion limitation. For rationale, retired EV battery with 70 to 80% capacity can be reused to cut waste and cost, while green hydrogen stores surplus renewable energy for later use. And for the last one is system configuration. A refurbished EV battery banks provide rapid frequency control, voltage support, and peak shaving. For the next part is potential benefits and impact. Economic advantage, environmental benefits, and social benefits. For economic advantage, using second life EV battery cuts storage cost by 30 to 40%, while hydrogen reduces reliance on expensive peaker plants and creates local jobs. For environmental benefits, extending EV battery life reduces mining needs, and green hydrogen provides zero emission long-term storage to lower greenhouse gases. And for the last one is social benefits. Hybrid system improve energy reliability for remote areas and critical facility while supporting public health through cleaner energy. For the challenge and risk mitigations, technical challenge, second life EV batteries vary in performance and hydrogen poses safety risks requiring strict testing, safety standard, and leak prevention system. And for the second one is economic and market risk. High upfront costs for hydrogen system need to be reduced through subsidies, partnership, and long-term contracts. For the next one is regulatory and social acceptance. Public trust and clear regulation are essential for hydrogen adoptions, supported by education, stakeholder engagement, and safety standards. And for the last part is conclusion. What we can conclude from this presentation, which is energy storage system improve grid reliability, and while pump hydro dominated bulk storage, lithium-ion batteries are growing fastest due to falling costs, offering flexible, efficient solution alongside hydrogen and other technology for diverse application. That's all for me. Thank you so much for watching.